In this project, the creator sets out to build a homemade RC tank, not just for the challenge, but to finally bring a long-time idea to life. Bringing something like this to life isn't just about tools or skill. It's about patience, vision, and really caring about what you're building. Inside the workshop, it's all happening step by step. Pieces of raw steel are cut, shaped, and worked by hand. You see the sparks fly, measurements checked and rechecked, and everything done carefully to make sure it all fits together and lasts. Nothing here is rushed. The build comes together in stages, with each part adding to something bigger. A lot of it is handmade, and using metal throughout gives it that solid, authentic feel. As the process unfolds, it's more than just assembling parts. It's watching something take shape, slowly turning into a powerful machine built with both skill and passion. The build starts with the tracks. They're what give the tank grip and keep it moving smoothly over different surfaces. So getting this right is a big deal. The tracks are built like a proper heavy-duty system, designed to handle stress while still moving smoothly and staying precise. Next up are the road wheels. They aren't just for show. They guide the tracks and make sure everything moves smoothly. They're made in pairs, and when the tracks are finally slipped into place, the grooves in the wheels line up perfectly with the guide teeth on the track. This keeps the track centered so nothing slips or derails. When the wheels are installed, the tank's weight isn't sitting on just a few points anymore. It's spread out across all of the wheels. This load-sharing setup is key because it eases the stress on each part and helps the tank move over rough ground without struggling. Next comes the drive sprocket, the part that actually makes the tank move by transferring power from the motor to the tracks. The build starts with the dual sprocket plates, those toothed rings that fit perfectly with the track's side chains. Each plate is checked thoroughly, and any tiny imperfections are smoothed out. Even small flaws could throw off the track engagement or cause parts to wear out faster, so every detail matters here. At the center of the sprocket is the hub, a solid cylindrical piece of metal that connects the plates to the tank's motor or transmission. It's carefully slid onto the drive shaft, lining up perfectly with the internal splines or keyway to lock it in place. Next up is the lower hull, the tank's backbone, and the base everything else will sit on. Assembly starts with the classic tab and slot method. Instead of just bolting things together, tabs are slipped into their matching slots, and the builder carefully guides each panel into place and welds it. With the drive sprocket mounted on the pillow block bearing, the build moves onto the suspension system, the part that really brings the tank to life, giving it movement, flexibility, and the ability to absorb shocks. Every little detail is made by hand, using steelworking techniques. In the workshop, it's all about focus and precision. Raw sheets and rods of steel are cut, filed, and shaped to fit exactly what the tank needs. Each piece is carefully checked for thickness, smooth edges, and strength, making sure it will fit perfectly into the bigger assembly. The L-shaped arms are prepared and will be fitted into their cylindrical housings, forming the core of the system. This setup works like a torsion bar suspension, just like in real tanks, giving a smooth, predictable response. As the arms move, the torsion bars twist inside their housings, storing energy that pushes the system back to neutral. The creator assembles the track tensioner system, also known as the idler adjuster, that ensures the tracks remain properly tensioned under all operating conditions. The components, including the idler wheel, spring-loaded arms, and adjustment screws, are cleaned and lightly lubricated to allow smooth movement once installed. The builder installs each suspension unit one at a time along the hull, fastening the mounting points with strong bolts. As each wheel is attached to its spring, the coil naturally compresses under its own weight. Mounting them this way lets each wheel respond on its own to bumps and uneven ground, giving the tank smoother, more controlled movement. The idler axle assembly connects the rear non-powered wheels of the RC tank and has three key jobs in this heavy metal build. It keeps the wheels perfectly parallel, so the tracks don't slip or derail. Acts as a cross brace for the hull to prevent the sides from bending under track tension, and allows fine-tuning of the track width by adjusting the nuts on the axle. The master installs the return rollers, which support the heavy upper run of the metal track as it moves back from the drive sprocket to the idler wheel. Without these rollers, the track would sag under its own weight. The dual clutch drive, often called the steering brake, is the mechanical brain that controls the tank's movement. Before assembly, the drive shaft and clutches are carefully inspected to ensure everything is clean, smooth, and properly lubricated. Basically, it all comes down to how the clutches work. When both of them are engaged, power is sent evenly to both tracks, so the tank just moves straight ahead. But the moment you ease off one clutch, power to that track drops, and the tank starts to turn in that direction. It's a simple setup, but it gives really precise control over how the tank moves. At the bottom of the hull sits the clutch and brake control setup, made up of several brackets and control arms all working together. The actuator brackets act as solid anchor points, holding everything in place and properly aligned. In the center, a dedicated bracket carries a bearing that supports the long drive shaft, preventing it from wobbling or bending under heavy load. Steering a heavy steel tank really comes down to controlling how power is sent to each track. This setup makes that possible. By sliding the clutch components back and forth, power to one track can be reduced or cut, which brings the tank around in that direction. On many of these custom systems, pushing the lever further also engages a brake on the dead track, allowing for much tighter, almost pivot-style turns. And since the drive shaft is long and constantly under serious load, these internal supports are crucial. They keep everything aligned and steady so the gears stay properly meshed and don't wear out or strip. A high-torque electric motor drives the steering clutch system through a chain drive. This is what actually puts everything in motion, letting the tank move and steer under RC control. The shaft, held in place by vertical steel brackets, and bearings, carries that power from the motor-driven chain straight into the main dual clutch assembly. This is where everything comes together, a fairly complex mechanical setup that splits power from a single motor between two independent tracks. Right in the middle, a roller chain brings high torque power down from the motor to the main drive shaft. From there, a pair of cylindrical components acts like switches, turning each track on or off as needed. Chains then carry that power from the clutch hubs out to the final drive sprockets, which are what actually move the tracks. Up top, a control rod holds two cone-shaped cams. As the rod slides left or right, driven by an RC servo, those cams press against the clutch levers to engage or disengage power on each side. It's a clever mechanical system that turns a single input into precise, independent control of both tracks. In a heavy RC tank running on a single motor, this central assembly acts as the brain of the drivetrain. The input pinion gear sits between the bevel gears, meshing with them at a 90-degree angle. It takes the rotation from the motor and redirects that power to drive the cross shafts for the left and right tracks. The torque splitter is the heart of this system. It takes power from the main drive chain below it and sends it out to the two clutch packs on either side. This setup is stronger and more versatile than using simple clutches alone, because it allows both tracks to stay powered even during turns, letting the tank push through mud, climb over obstacles, and keep moving smoothly. The creator builds a mechanical power distribution hub that takes rotation from a single main motor and splits it between the two independent track drive chains. It combines planetary-style bevel gears with chain drives to control exactly how much power goes to each side. The system works in three main stages. First, the large motor at the top drives the central chain. That spins the main cross shaft, giving both tracks their forward and backward movement at the same time. The heart of the system is the center bevel gear. The motor turns both of them at the same speed, sending equal power out to the left and right output chains. Then, a smaller steering motor rotates the small center pinion gear. This speeds up one bevel gear while slowing the other by the same amount. Essentially, the system borrows power from one track and sends it to the other, letting the tank maintain its overall speed while making a smooth, powered turn. Finally, the four vertical chain drive pillars carry this blended power down to the final drive shafts, which exit the hull and turn the heavy metal tracks. It's a clever setup that keeps the tank moving smoothly, even on tough terrain. The road wheels do most of the heavy lifting. They're in constant contact with the inside of the track, carrying the full weight of the tank and spreading it out evenly to keep ground pressure down. The dual wheel design isn't just for strength, it serves a purpose. The center of the track, known as the guide horns, runs right through the gap between the two wheels. That keeps the track aligned and stops it from slipping off, even during sharp turns. The builder puts together a heavy-duty, custom-made servo-controlled shifter box, basically the gearbox and steering actuator for the RC tank. Its job is to take a small electrical signal from the receiver and turn it into real mechanical force, enough to move gears or clutches inside the system. In practice, this unit acts as the steering executor. When the steering input is triggered, the servo pulls on the blue rod, and that motion is transferred straight into the mechanism. That movement slides the internal gears or shifting forks back and forth, engaging or disengaging the drive for either the left or right track. By shifting the internal selector, one track stays powered while the other is either freewheeling or lightly braked, which brings the tank around smoothly in the desired direction. He then mounts a key piece, the output drive sprocket, along with its retention system. This is the final point where power leaves the gearbox and gets passed on to the tracks. The sprocket's teeth are shaped to mesh with a roller chain, which carries that power out to the main drive sprockets on the outside of the hull. The splined shaft makes sure everything stays locked together. It keeps the sprocket from slipping, so all that torque from the motor is transferred cleanly and efficiently into the drivetrain. It's a simple connection, but it's doing a lot of work. The creator fabricates a cooling tray from a steel plate, built to hold two high-volume electric fans. In a large metal RC tank, heat builds up quickly between the high-torque motors, gearboxes, and speed controllers. Things can get hot fast. These vents give the fans a clear path to move air through the hull, either pulling in cooler air or pushing hot air out. Right now, he's working on fitting the side skirt onto the tank, taking his time to line everything up just right. It might look like a simple add-on, but on a heavy-duty RC build like this, these metal plates actually do a lot more than just make it look good, though they definitely give it that modern main battle tank feel. On real tanks, side skirts are there to protect the suspension. And it's the same idea here. They help cover up all those moving parts underneath, which are constantly taking a beating when the tank is running over rough ground. But there's also a really practical side to it. These skirts act like a guard, keeping rocks, dirt, and mud from getting thrown up into the mechanics. And with a setup this powerful, a high-torque chain drive, and spinning road wheels, nothing getting caught in there is a big deal. Even something small can cause a jam or slowly wear things down over time. At the front of the tank is the main body section, what's known as the glacis plate. On a real tank, this is usually the most heavily armored area. He's now hand-fitting the custom-bent metal rods along the surface. On full-size tanks, the crew members use them to climb up onto the hull. At the front of the tank is the main body section, what's known as the glacis plate. On a real tank, this is usually the most heavily armored area. Here, though, it's been set up as the main access point, almost like a maintenance bay where everything inside can be reached. Spare track pads are mounted along the hull. On a real tank, these aren't just for show. They're kept there for quick repairs. If a track link gets damaged by debris or something more serious, the crew can unbolt a spare and swap it in right on the spot. A gas strut has been added to make handling the heavy, all-metal hull a lot easier and a lot safer too. With the upper hull and front glacis plate built from thick steel, the whole section has some serious weight to it. The strut, filled with pressurized nitrogen, helps balance that weight. For power, the builder has gone with sealed lead-acid batteries to run the whole vehicle. On something this big and heavy, that choice makes a lot of sense. These batteries can store a lot of energy, so the tank can keep going for a long stretch, often well over an hour, before needing a recharge. The hull is constructed from heavy-gauge mild steel, which gives it the right amount of weight for solid traction and the strength to withstand rugged off-road conditions. Every bump, rock, and slope is absorbed without compromising the structure, making it built for serious outdoor driving. Integrated into the hull is a main maintenance hatch, thoughtfully designed to provide easy access to the internal components, like batteries and motor controllers. This means all the essential work can be done quickly without having to disassemble the entire body, keeping maintenance simple and efficient. At the front, the nose section features a steep, angular slope. This is a hallmark of modern tank design. On a real vehicle, it's meant to deflect incoming fire. In this build, it adds that same aggressive, sleek look, giving the tank an authentic presence, even at scale. The Creator manufactures the sponsons, the triangular sections along the sides of the hull, which serve several important purposes. Inside, they create extra space for wider components. On the outside, they act like heavy-duty fenders, keeping mud, rocks, and debris from being thrown up by the tracks and landing on the turret or engine deck. On a real tank, these sloped side plates act as spaced armor, helping protect the upper track area from anti-tank rounds. The triangular shape isn't just about looks, it's incredibly strong and helps stiffen the entire side of the hull. In this build, the sponsons combine practical functionality with a realistic look, making them both useful and visually striking. The rear of the hull houses the high-torque motors and electronic speed controllers, which naturally generate a lot of heat during operation. The mesh covering helps with airflow, letting heat escape. This periscope housing is one of the key components on the tank. It's there to protect sensitive glass optics from shrapnel and harsh sunlight. Next up is the assembly of the commander's and loader's hatches. These are modeled after the ones seen on modern Western tanks, giving the top of the tank a realistic, functional look. Surrounding the base of each round hatch are small rectangular metal boxes. These represent the vision blocks. On a real tank, they hold thick armored glass, letting the crew see outside while staying protected. For this build, the hatches are made from multiple layers of steel, giving them the right thickness and weight. This not only makes them look authentic, but also adds a solid, durable feel, just like the real thing. At this point, all the parts and details have been fitted into place. What started as an open framework is now fully closed in, with every exposed section covered and tied together into a complete structure. Panels, plates, and small details all come together, giving the upper hull of the tank a solid, finished look from every angle. A tank turret bearing race is a heavy-duty mechanism that lets the turret rotate a full 360 degrees smoothly. It's made up of concentric steel rings with ball bearings or rollers sitting in precision grooves. These rings are mounted between the hull and the turret, supporting the turret's weight while allowing it to turn freely and reliably. It's a critical component that ensures the turret can move accurately without binding, even under the weight of all the armor and equipment mounted on top. The builder is installing a high-torque DC gear motor, which is the powerhouse behind the turret's rotation. In a heavy, all-metal build like this, it's responsible for moving the massive turret smoothly and reliably. The gearbox trades speed for torque. This setup allows the turret to turn slowly and steadily, even when the tank is moving on slopes or rough terrain. On top of the motor sits a small toothed wheel, the pinion gear. This gear meshes perfectly with the large ring gear bolted to the hull. As the motor spins, the pinion walks around the ring, turning the entire turret a full 360 degrees with precision. The creator now begins assembling the main gun system, starting with one of the most important parts, the gun mantlet. This is the heavy, triangular metal sleeve that sits right at the base of the barrel, and it's built here from thick, welded steel plates to give it real strength and presence. On a real tank, the mantlet is a critical piece of armor. It acts as the pivot point for the gun itself. Hidden behind it are the trunnions, the internal axles that allow the gun to move up and down smoothly. These trunnions carry the weight of the gun and handle the forces from recoil and movement, making them absolutely essential to how the whole system works. The barrel is fabricated from a high-grade seamless steel tube, and that choice is absolutely key to how the whole system performs. On real tank guns, the barrel has to handle extreme conditions, massive internal pressure, intense heat, and repeated shock every time a round is fired. That's why they're typically made from high-strength alloy steels, like chromium-molybdenum blends designed specifically to resist wear, heat, and deformation over time. It's a locking bracket, used to hold the barrel or mantlet in a fixed position when needed, whether that's during transport, maintenance, or just to stop the gun from shifting under its own weight. Once released, the gun is free to move again, allowing it to travel forward and back smoothly as intended. In a real tank, once the trigger is activated, the firing mechanism ignites the propellant inside the round. This creates a rapid expansion of high-pressure gas, and that force forward, down the barrel. This powerful push sends the projectile out at high speed. At the same time, the gun experiences recoil, the equal force pushing backward. To handle that, tanks use recoil systems with dampers and return springs. They absorb the shock and bring the barrel smoothly back into position after each shot. The breech acts like a heavy-duty door. When it's open, it allows access to the chamber so a round can be loaded. Once everything is in place, the mechanism slides or swings shut, sealing the back of the barrel completely. Now the gun elevation mechanism comes into play. This is what allows the barrel to move up and down smoothly and stay exactly where it's aimed. The actual movement comes from a drive mechanism. When the motor turns, that motion is passed through a set of gears to a toothed arc, or rack connected to the gun cradle. As the gear rotates, it pushes or pulls on that arc, causing the barrel to tilt up or down in a controlled, steady motion. The feeding mechanism is the system that gets each round into the gun and ready to fire. In modern tanks, this job is handled by an auto-loader. When it's time to fire, the system selects a round, brings it into alignment with the barrel, and then pushes it straight into the chamber. Once it's fully seated, the breech closes and locks, preparing the gun for firing. Now he's moving on to building the components for the pressurized system. This is what will bring the smoke effect to life. This system combines heat and pressure. The heating element generates the smoke, and the pressurized air pushes it out with force, creating that dense, pulsing exhaust effect. So instead of just a simple smoke unit, this setup is designed to feel more alive. When the system kicks in, the smoke doesn't just appear, it gets pushed out like a real engine breathing under load. It's the same principle used in many RC smoke systems, where airflow and fluid vaporization work together to produce a realistic result. Inside the hull, everything is carefully wired and laid out, all the control electronics working together as one system. Power starts at the batteries and is distributed throughout. Every action, driving, turning, rotating the turret, and even operating the gun comes down to commands being sent through these connections, telling each part what to do and when to do it. The pressurized system is built around two large gray cylinders, which serve as storage tanks for the pressurized air. These act as the reserve, holding the pressure that will be used throughout the tank whenever it's needed. The pressure gauges are mounted to show constantly what's happening inside those tanks. Keeping an eye on that pressure is important, especially with a custom-built setup like this, making sure everything stays within safe limits. On top of the tanks, the blue and black L-shaped pieces are quick connect fittings. These allow the orange pressure lines to be routed neatly to different parts of the tank, making the whole system easier to manage and adjust. This 12-volt DC pneumatic solenoid valve is an electromechanical device that controls airflow by converting an electrical signal into motion within the valve itself. When voltage is applied to the solenoid coil, it creates a magnetic field that moves an internal plunger or spool, opening or closing air passages inside the valve body. This lets compressed air flow into or out of a pneumatic circuit exactly when and where it's needed. These valves are essentially used as directional control valves in pneumatic systems. Electrical signals from a controller or receiver trigger them to route compressed air to different actuators or cylinders. Rather than letting air stay trapped in the supply line, the solenoid valve directs it to the right place at the right time. In the context of a large-scale RC tank, that's exactly how they're used. They act like the muscle behind the compressed air system, turning electrical commands into controlled bursts of air to operate pistons or cylinders. The painting process starts with a fast-drying industrial alkyd paint that serves as the primer. It's ideal for metal surfaces because it adheres well, dries quickly, and stands up to the elements. Once the base layer is dry, a top coat of nitrocellulose-based lacquer is applied. This gives the tank its final color and matte military finish, while also protecting the underlying paint from scratches, oils, and general wear from handling or outdoor use. The last step is all about adding realism. The builder mixes paint with iron filings, or special salts, to trigger a chemical reaction that produces real rust on the hull and tracks. This weathering creates a battle-worn, lived-in look, transforming the fresh paint into a convincing replica of a tank that's seen action. At the heart of this incredible build is the builder himself, a craftsman whose patience, vision, and creativity are evident in every weld, every carefully cut steel plate, and every tiny detail. This isn't just about assembling metal and electronics. It's about bringing a vision to life, turning raw materials into a working, breathing miniature of a real battle tank. And then stepping back, the scale really comes into focus. This is a 1:6 build, stretching about 140 centimeters in length and reaching roughly 2.1 meters with the barrel fully extended. It's over 70 centimeters wide, stands close to half a meter tall, and weighs around 350 kilograms. At that point, it stops feeling like a model. It feels like a machine in its own right. If you enjoyed this build, be sure to subscribe to our channel and keep an eye out for more exciting videos coming soon. Hit the bell, give this video a thumbs up, and share your ideas in the comments.